Okay, we have a sensor data, temperature is being maintained, okay, it is displayed, pressure is there, humidity is there, other parameters are there, vibrations are there. Means vibration sensor is measuring and collecting the vibrations, and alert is there because of high vibration detected. Okay, so we have production defects and all kinds of analytics are there for every part, every machine which is being in your in your smart factory. You have AI dashboards like this. Okay, you come to know without visiting the factory. You are sitting in the office with your single chair, assembly line production is going on, and you come to know where the problem is, what should be done, what should be replaced. And this also, if that employee switches or retires, new employee can automatically adopt at the same efficiency, okay, at same level. He is also same informed as the previous one, because everything is automatic, it is visible. Now decision making, so it has a data input from various sources, okay, then AI processing is being done, there are feedback loops, okay, and then action is executed, and this is what the decision making happens. This is how through the decision. So the first thing is what you need is you have a data. Data is there, you have AI systems that process the data, and there is a feedback loop which continuously improves the decision taking, and then you have action and execution. So this is how it is happening. Clear? Any doubts? So role of robotics. Now first part is over. Industry 4.0. I've given you brief introduction, how it happens, what are inside things are there. Now we'll talk about robotics. So first thing is that we have Internet of Things, then we have processes, okay, then we have production line, then we have a robotic arm, okay, and then we have machine learning. So these 5 components are actually part of automation right now in Industry 4.0. Clear? Earlier we did not have this machine learning part. We had robotic arm, okay, that is Industry 4.0. If you remove this Industry 3.0, that means we have a production line. Clear? So this is how the parts of automation. Clear? Very simple with infographics, easy to comprehend. Now, there are various types of industrial robots, and you should know what and how, which kind of robot being used and where it can be, where it is used. So industrial robots refer to use of programmable machine in manufacturing and industrial environment to perform tasks like assembling, welding, painting, material handling and packaging. And remember, these are repetitive tasks, okay, where humans commit lot of mistakes. Lot of accidents happen on the assembly line. People have got limbs, fingers chopped off because of safety, because it was a repetitive task. You started talking to your colleague, you're working on a machine, and your hand was accidentally inserted into a moving part, and accident is there. So we have robots where we have a repeated task at a high speed, accuracy, precision is required, and task is assembling, welding, painting, material handling or packaging. So you can employ a robot. Okay? So these robots are automatically controlled, highly precise and fast, capable of working continuously, used to improve productivity, safety and quality. So you use robot, so you get 4 benefits. Now first type of industrial robot is articulated robot. That means multiple joint robotic arms like human arm, It has various degree of motions. Okay, the first is T axis, B axis, U axis, R axis, L axis. So that is basically the degree of motion. So very flexible, and where it is being commonly used, welding, painting and assembly. So these are, and normally in engineering college like Malika and others, they demonstrate this kind of robotic arm. Okay, that can pick something. If you change the tool over here, okay, instead of polishing it can do drilling. Okay, and you just change the tool, it will move to the precise location, do a hole or make a drill for you, paint the surface for you and come back. And the speed, you can control the speed also. Then we have Cartesian robot. As the name suggests, they are capable of moving X, Y, Z axis. Okay, they have high precision. Simple design uses are being, they are used in CNCs and 3D printing. You have seen a 3D printer, something like this. Okay, this robotic arm is actually stamping these boxes. Okay, so these are known as Cartesian robots. Then we have SCARA robots, best for horizontal movements, accurate, used in assembly lines for electronics. You have a PCB board, you have to install the components, you have to do weldings, soldering of that components. What you use? SCARA robots. Okay? So this is the third type of robots. Then we have a Delta robot. Now what the Delta will do? It is lightweight, very fast, used in packaging and sorting. Ideal for small and lightweight parts, items. So suppose that you have to sort an item. Now this Delta robot will actually pick an item which is not in good quality. So it will remove from that line. It will drop down to the floor or will collect that item to some bin for discarding. So this is the work of Delta robot. Now we have a collaborative robot, last one. So the collaborative robot, they actually help humans, okay, where safety is major concern. So we have collaborative robots. They are easy to program and flexible because as per your need, you can program them. They will help that human being. Suppose what happens? Suppose that you have to take part out of that machine at a very desired speed, at a very precise speed. One simple fatigue can actually chop off your fingers or limb. So this Delta collaborative robot, you have a robot, you program it, at precise moment it will go inside the machine, pick the part, okay, and come back. So this is what a collaborative robot is there, working alongside with the humans, easy, flexible for in programming, and used in small scale and flexible productions. Now advantages of robotics: efficiency, accuracy. Challenges: cost and skill. To install a robot, you invest a lot of money. And skill means that you have to keep a programmer which can do, because these robots have special type of programming language. You have to learn that programming language, write a program in that language and test the program. Okay, so that skill programmer should be available to you. Okay, the human robot interaction, that is HRI. The focus is work together safely and efficiently. The safety is major concern. So prevents accidents, enables a safe shared workspace. So that means ensuring safe collaboration between human and robots. Use of sensors, camera, vision system to detect human presence. Emergency stop mechanisms are there. Speed and force limitation. The ISO standards are 10,000 to 180 and ISO RTS is 15066. So this is the standard that of safety robots. Physical safety tools like light curtains, safety mats and protective barriers that you have to use. So this factor you have to keep in your mind in your smart city, smart factories, if you are using robotics. Okay, now usability. Improve productivity by making robots accessible to non-experts. So suppose you have an expert employee retired, you want to replace that employee. So if you have this HRI factor with you, so you can replace that employee easily. Okay, because this robot will help assist that employee. Employee will learn, the worker will learn easily how to work on your assembly line. So designing robots that are easy and intuitive for humans to use. User-friendly interfaces should be there, touch screens, teach pendants, voice controls. Simplified programming and operations. And one of the most important thing is ergonomics. I think present student don't know about ergonomics, but earlier means student of my batch of engineering, they know ergonomics. There is a simple ergonomics means there is a definite temperature that should be maintained inside a factory or a workplace, so your body feels comfortable. You are not stressed. You are not over sweating like in these humid conditions. AC and proper control is there. If the temperature is too high, you will sweat. Your energy will drain off. If your temperature is too low, you will feel cold, shiver, and you will not be able to work properly. Your table height is designed at a level where your taking average height of your general population. Okay, so that you do not have to work like you're putting your hand on top of the table or it is too low. So this is ergonomics. And at one level. Another level of ergonomics is that suppose you have to move this item from this place to some another unit in the production line. So the physical movement, okay, to move this item should be as minimum as possible. So you have better efficiency, less accidents, and less fatigue. So these all was study of ergonomics. Anyway, quick setup and adaptability for different tasks. Okay, you know, restaurant tables are very ergonomically designed. They are neither too high, neither too low, so that you can properly dine. Okay, clear? So, ergonomic designs for comfortable human interaction, quick setup and adaptability for different tasks, reduced training requirement for operators. So this is what usability counts. Okay, so automation levels are there. First is the manual. All tasks are performed by human. Okay, so this is level 0. Example, hand assembly, traditional workshop. Level 1, assisted automation. Basic tools and machine support to humans. Like instead of manually drilling the hole, you have a proper tool. Okay, drill machine is there that can drill. Example, power tools, basic machinery. That is level 1 automation. The 7.2 is semi-automation. So we have machine handles the repetitive task, humans supervise and control the operation of that machine. Example, CNC. Okay, so CNC machine is level 2 automation. Okay, or conveyor system. Automated level 3, system operate with minimal human intervention. Example, automated assembly line. So it is all pre-programmed. One part moves to only one specific direction or at one specific distance. Other robot handles the next part. Other robot handles the next part. Okay, 4 robots collaboratively are welding on the same assembly line on a chassis of a car. So your car chassis is being welded in one single shot. Okay, for paint shop, the car goes to a paint bucket. Robot picks up the entire car, dips into the bucket, pulls it out. Okay, sends to the drying area. As soon as the car reaches the drying area, specific temperature is maintained, and your car entire paints dries off at a same speed. So that is why when you have a car, there are no dripping marks. There are no dripping marks because every surface of the paint has dried at a constant rate at constant speed. Right? This is because we have industrial ovens. Okay. Now fully automated and autonomous level 4, that is self-operating systems with AI driven decisions. Real-time optimization and adaptability is there. Example, smart factories and autonomous production line. So we are at level automation level 4. Okay, for smart factories. So these are the 4 levels. Now whenever you see some worker in a garage working with power tools, you will come to know that it is level 1. Okay. Now this is, if you have understood everything, now we can put back. Now predictive maintenance. So we have a machine is working. Machine is actually through sensors, it is logging the data and sending to an AI model. It is feeding the data to the model. The model is what is doing? It is